Welcome back everyone. In today's session we are going to see some important examples from the textbook along with some more questions. So in the last session we have seen some examples of marbles, different colored marbles, and we have seen the spinner, the probability of getting different colors on a spinner, and many more things. Now let's today see the example of tossing a coin. When you toss a coin, okay, when we toss a coin we get either heads or we get either tails, okay, but nobody can surely say that you'll get heads only there, okay. Nobody can surely say that you'll get heads. You may get heads on the coin or you may get tails on the coin. So this is called sample space. What do we call this? Sample space. S, you can denote it by just S also. The number of possible outcomes in an experiment is called sample space. So suppose if you selected heads, you were tossing a coin for a game and you selected heads and your friend selected tails. So what is the probability of you winning the toss? Probability of heads. So number of favorable outcomes, you can see the formula here. So your favorable is heads, you wanted heads, so that is your favorable. It is how many times? One time. And total number of outcomes are how many here? 2. So 1 by 2. Your friend selected tails, so his favorable is tail, and that is how many times? It's one time, so 1 upon 2 total number of outcomes. This is one simple example of tossing a coin. So we can say probability of getting heads is 50% and probability of getting tails is also 50%. So we have 50-50 chance of getting heads or tails when we toss a coin. That is the reason we toss a coin before we start any game or before we decide between any two teams, okay. So this is tossing a coin one time, okay. The number of outcomes are 2. Suppose if we see an example here now, here you can see 2 coins are tossed how many times? Tossed 500 times, and we recorded the outcomes. 2 coins are there, okay. 2 coins you are tossing. On both the coins you may get heads, yeah, heads, or on one coin you may get heads, other coin you may get tails, yeah, and on both the coins we can get tails also. This is also there, yeah. 3 options we have. When we toss 2 coins we have how many options? 3 options. Just imagine 2 coins are in your hand and you tossed. You may get heads, you may get head, tail, or you may get tail. There is no 4th option in this, okay. So how many times they have got heads? Let's check here now. This option they tossed it 200 times, 500 times, sorry, 500 times. So out of those 500 times, heads we got how many times? 105 times. One head means this one, we got how many times? 275 times. And no heads means that is both the tails, we got 120 times. Clear? No heads. So like this we got all the 3 outcomes, and 500 times we tossed and we recorded our outcomes. Now he is asking find the probability of occurrence of each of this event. So P of E1, I can say each of this event means will denote the 2 heads by E1, 1 head by E2, and this is by E3. We can write E1, E2, E3 also, or you can write 2 heads, 1 head, or no head, one by one, okay. That's up to you. So the formula, what is our formula? Number of favorable outcomes by total number of outcomes. Okay. So what is the probability of the first? He is asking. E1. E1, that is 2 heads, is 105 times favorable by 500. When you divide, you will get 0.21. Then E2, probability of getting 1 head, I have named as E2. So it's 275 times favorable outcomes, 275 by 500. Again divide, you will get 0.55. Then 120. Next is what? 120 by 500. So here total number of outcomes were 500. Okay, and these are the favorable outcomes. We can find the probabilities. Next one, you can see example number 3. In this example, a die is thrown 1000 times. 1000 times we throw the dice. So when we throw a dice, you know very well what are the different outcomes we get when you throw a dice. There are 6 possible outcomes on a die. 1, 2, 6. We can get 1, we can get 2, 3, 4, 5 or 6. So when you throw a dice, you may get any of these outcomes. Okay. So how many times we have thrown a dice? 1000 times. So we got different outcomes. 1 we got 179 times. 2 we got 150 times. 3 we got 157 times. Goes on like this. So these are the frequencies of the outcomes. Now we have to find the probability of each one of these. So same way, probability of E1. E1, I'll take this as E1, first one, 179 by 1000. Then E2, this will be for E2. Then probability of E3, 157 by 1000. Then E4, 149 by 1000. Sim goes on. Okay. Then for fourth, E4, 149 by 1000. Then E5, 175 by 1000, and last is 190 by 1000. When you divide this all, you will get the numbers in decimal, and when you add this all, the probabilities, you will see an amazing answer. When you add up all these numbers, E1, E2, E3, E4, E5, E6, when you add this all, you will get 1 always, because these all are complementary events. Okay, and you can see all the probabilities lies between 0 and 1. There is no probability which is more than 1 here. Okay, and less than 0. Probability cannot be less than 0. It cannot be less than 0, nor it can be more than 1. It will lie always in between 0 and 1. Okay, so this is the way we do the examples. Now next example, 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized conditions favorable to germination. After 20 days, the number of seeds which had germinated in each collection were counted and recorded as follows. So you know germination of seeds, when you put seeds in water for a night, they will get germinated. 50 seeds were selected at random from each of 5 bags. So we were having 5 bags of seeds. How many? We were having 5 bags of seeds. From each bag we have taken 50 seeds. 50 seeds we have taken, and we kept them in for germination. So from the first bag only, so all 50 seeds will not get germinated. Okay, so from the first bag only 40 seeds got germinated. From the second bag only 48 got germinated. From the third one 42 got germinated. So this way germination process took place. Now he is asking you to find the probability. Now from these all, if we have to find the probability. What is the probability of germination of more than 40 seeds in a bag? More than 40 seeds in a bag. How many bags have more than 40 seeds in this? You should see that. Okay, let me erase this so that you should not get confused with it. Okay, the first one he is asking, what is the probability? Now these seeds are with us. Now he is asking what is the probability of germination of more than 40 seeds in a bag. How many bags have more than 40 seeds? Total bags are 5. What is our total number of bags? 5. Total 5 bags. Okay, 40 seeds, more than 40 seeds, how many bags have? 1, 2, 3. 3 bags have more than 40 seeds, so our probability will be 3 by 5. The next one, 49 seeds in a bag, second one. So how many bags have 49? There is no bag which has 49, so 0 by 5, impossible. Then more than 35 seeds, more than 35 seeds, how many bags have more than 35 seeds in this? Yeah, 40, 48, 42, 39, 41, all these are more than 35, so our probability will be 5 by 5. Okay, 5 out of 5. So this is the way we have to do the examples. Okay, hope it is clear to you all.